Yeah, quick one today. Looking over everything for the exam. There's enough on that. So, slides I'll cover today, mostly review from last time. There's stuff that's underlined in the upcoming slides or what's important for the exam. The rest of the stuff is just background or for your own benefit, I guess. And then got a couple of review slides and outline at the end. So yeah, hope that's, we'll let that be that. Review session Sunday. I'll post the link on D2L this weekend. Before I dive in though, questions, concerns, anybody? All right, let's do it. So, tobacco's bad. Toxicology primarily revolves around the effects that it has on our cardiovascular disease functioning as well as development of pathology. Due to the fact of all the chemicals in there and it gets combusted, tar is a big bad one. Carbon monoxide is a big problem. Lots of other stuff in there. Big problems. Nicotine is seen as a carcinogenic, and that's a little debatable. I mean, you can show that it will develop, yes, pancreatic cancer through activation of specific receptors, but yeah. Due to the fact that it's in a low, it's about 30% of active cigarette smokers develop pathology, so I don't know. Right. Carbon monoxide presence causes hypoxia just due to its effect on hemoglobin. We've covered this before, I believe. Last time we talked about stopping cigarettes, or at least nicotine patch is one of the NRT or nicotine replacement approaches. Has some efficacy, but as it states, high relapse rates with everything really. Talked about a couple of pharmacological interventions, bupropion. This is the dopamine norepinephrine transport blocker. Some success rate, or twice that of placebo, but you have to be on it for it to work. Varenicline is another one, partial agonist at alpha-4 beta-2. This can provide some, or better relief, or better relapse rates compared to bupropion, but still at the same time it's not. Other studies show it's kind of in the same area. And then more specifically, yeah, so just for these two, know what they do. Bupropion is a transport inhibitor for dopamine, norepinephrine. Some success rate, but again, you have to be taking it for it to work. Thought is that it can help keep your mood more stable compared to total abstinence, and therefore will hopefully help with weight gain. It's actually been, Wellbutrin is prescribed for weight loss, even to non-smokers, but it's very individual by individual basis. Some get a great benefit out of it, others don't feel anything at all. So yeah, but exactly, works through modulation of reward pathway, and works for some, not so much for others. And then for varenicline, just know it's a partial agonist, alpha-4 beta-2 nicotine acetylcholine receptor. Better abstinence than bupropion, but all in all, it's still not that successful. Works for some, doesn't work so great for others. So, yeah. Vapes were invented, or vaping was invented. Chinese pharmacists in the early 2000s developed this as a potential for quitting cigarette smoking, where you could have a nicotine-containing aerosol that is breathed in, and so it provides or it delivers nicotine to people without actually having to combust organic material, to the extent that you do with smoking, because it's not just an aerosolization, there is a heating element to it. So yeah, patent in the States a couple of years later described an electronic automation cigarette that can substitute for quitting smoking. Then a handful of years after that, it was marketed as a healthy alternative to tobacco smoking, useful for quitting smoking, and a way to circumvent smoke-free laws. And I think we've all seen that's really gone by the wayside. You really can't vape anywhere. First couple of years you could vape everywhere, and then they quickly clamped down on that, and now it's not allowed anywhere, same as actual smoking. Yeah, all kinds of shapes and sizes to look like cigarettes, to look like a bomb. I guess we're not in TSA, so we can say the B word here, but whatever that is, it looks like that. That was the wrong thing to do. There we go, but just examples of these things. Big thing I talked about before is the difference between what you exhale, what's in what you exhale between a cigarette and a vape, right? You have a lot more stuff in the smoke than you do in the vape cloud, if you will. However, the stuff in the vape cloud, we went to that first. So what's in the vape cloud is also potentially dangerous though. So there's a lot more stuff in the smoke of cigarette smoke, but there's still a lot of stuff in the e-cigarettes cloud. However, it's the larger molecular weight stuff that is the potential dangerous or toxic chemical in vaping, right? So looking at a bit more specifically e-cigarettes here compared to standard cigarettes, a lot less stuff in the e-cigarettes, but it's still present is the bottom line. Acrolein that they're focusing on here is kind of interesting. It's just an aldehyde molecule that's incredibly toxic when it's produced from smoking, but it's actually, well, we have a shunt. You can actually make methionine, that amino acid, with this compound in a certain pathway. So acrolein is a compound that's in a lot of stuff. When it's consumed in food, it has no real effect on us. When it's consumed in some combusted organic material, it becomes toxic. So looking at these levels, there's a lot more of it in cigarettes than there is in vape, but the bottom line is they still have it in the aerosol from vapes. So not necessarily the cleanest thing, but the biggest problem comes from the higher molecular weight stuff in vape. So here we're looking at, this is roughly, y-axis here is size of things, is amount of substance present, plotted as a function of actual size in nanometers of things. So yellow is cigarette smoke, so we see a ton of stuff, but smaller molecular weight. Higher molecular weight stuff is from the e-cigarette, and that's where the potential heavy metals and that comes in. So back to what you need for the exam, just remember this. Toxicants are lower in e-vapes compared to tobacco smoke, but particulate matter, especially the higher molecular weight stuff in vapes, is also a potential concern with toxicity. So that's the big bottom line there. Okay, and then I showed some of these before, but just essentially what we're showing here is, so comparison between the patch, using the patch, and an e-cigarette, compared to continuous abstinence from cigarette smoking, and then it's plotted as a function of time from the quit date. And as you can see, regardless if you're using an e-cigarette, a patch, or just placebo, there's a decrease in the amount of abstinence over time, regardless of the method that you use. So unfortunately, cigarette smokers really just have to have the will to quit. There's pharmacological and other agents they can use to quit using cigarettes or nicotine, but success rate is very low, unfortunately, but that's kind of the bottom line. And then, yeah, not a huge statistically significant improvement with quit rates with e-cigarettes compared to other, so we have a bunch of studies here that looked at things, and the odds of quitting are still pretty abysmal regardless of the study that was done and how they tried to conduct the study. Seems like people get addicted to vaping, or the best case scenario is that you take on vaping rather than smoking cigarettes. again, neither of them are great for your health, but yeah, the thought is if you get hooked on that, it should be potentially better than cigarette smoke. So, okay, that's it for the nicotine stuff. I'll stop just for a second. Questions, comments, or concerns from that material? Okay, so a couple of things from the caffeine lecture. I want to go over these two slides. We talked about this before. I've had some questions, as well as I felt like the way the diagrams were set up might have been misleading. So I just want to walk through these two again real quick. Hopefully not to the annoyance of anyone in the audience, but idea here is we're talking about cognition changes as a function of caffeine presence in the cerebral cortex, right? So in this instance, we have a glutamatergic input from the cortex. We've got cortical glutamatergic interneuron here. This standard situation is on the left. The situation with caffeine is on the right. Standard situation, we have adenosine receptor A1 that gets bombed by adenosine. This is coupled with G-alpha I, so it's going to shut off adenylate cyclase. Glutamate from this neuron binds to its target receptor, causes an increase in the activity of adenylate cyclase. The overall effect is moderate levels of cyclic AMP. Overall effect is moderate glutamatergic output to the cortex, and you have moderate attention or cognition, okay? I think before I had like the T for inhibition. Just, yeah, remember it this way, please. But then with caffeine on board as an antagonist at adenosine receptors, everything's the same for the glutamatergic input on the right, but caffeine will block A1 receptor, has no effect then on adenylate cyclase. Aggregate is we have higher levels of of cyclic AMP due to activation of adenylate cyclase by the glutamate receptor. Here we have increased glutamatergic output and then enhanced attention and cognition, right? This is your first cup of coffee of the day. It's going to boost you. But that compared to, now we're talking about motor control in the nigrostriatal system as a function of caffeine presence at the A2A receptor. So on the left, input from substantia nigra. This is a dopamine neuron. Again, we've got adenosine here, but A2A receptor this time. Adenosine binds. This is G-alpha S coupled, so it's going to activate adenylate cyclase. But dopamine is binding to D2 receptor, so that's coupled to G-alpha I. So we have a similar situation. We have mixed inputs. The aggregate is moderate levels of cyclic AMP. That's going to cause moderate GABAergic output to the motor cortex. Controlled decrease in motor activity, okay? Then with caffeine on board, as an antagonist at A2A, all we're going to get is the inhibition of adenylate cyclase from the D2 dopamine receptor. Decreased cyclic AMP will decrease GABAergic output to motor control and then increase motor activity here. So, right, when we've got caffeine at the cerebral cortex, that will enhance attention and cognition. It will also, in terms of motor control in the nigrostriatal system, it's going to increase motor activity there, okay? Oh, and right, so this is not on the exam. I showed it, I believe, I cut this one up before, but just remember, situational specificity of tolerance is not on the exam, okay? I'm still figuring out how to explain this one in a manner that I'm satisfied with. I feel like it's more confusing than it needs to be, but just remember the situational specificity of tolerance. The learned tolerance with alcohol and caffeine won't be on the exam. Okay, so after that is just a bunch of outlines for the different modules that we've had in this section, okay? You can look through these. I won't read through this whole list and insult everyone here. You can read all of these, but this, yeah, all of this should be on the slides. So I believe we have 6, right? 3, 6, yeah. So those, yeah, I'll just let you read through the outline. Questions, comments, anything, please let me know if you have any concerns about those. But check those out. Then the last thing, I guess, we've got review session this Sunday at 7 again. Once that's recorded, I'll post it to D2L. Last thing I'll say, the class request lectures, this is what I've got so far. First lecture will be xylazine, and then its relation to the bath salts drug, ayahuasca, kratom, and kava. We'll do that first. Second one will be St. John's worts, inhalants, and then deliriants I didn't cover. That's actually the 3rd hallucinogen level. We didn't get into that, but I'll do a brief thing on that. And yeah, then I got a mystery drug I'm gonna throw on everyone that I hope everyone likes, but we'll see. So, that's it. Questions, comments, let me know, please. Hope everybody has a good weekend.